It is once again new machine day in the shop, and that presents us with a dilemma. We can either run this new milling machine stock, exactly as it came from the factory, or, and hear me out on this, we could bolt all of this stuff to it and convert it to CNC. Welcome back to Cloud 42, I'm James. We are starting a new CNC conversion project on the channel. I have been getting questions from viewers asking about the MASSO CNC controller. People want to know, how does it compare to Mach? How does it compare to the Acorn? And my answer up until now has been, what's a MASSO? Turns out it is a self-contained touchscreen CNC controller made by a company in Australia. It looked really interesting to me, so I ordered one and started looking around for a project. My first idea was to put it on the Grizzly G0704 mill that I previously had sitting right here, but I just had a really hard time getting excited about that project for a few reasons. One is the Grizzly mill had some problems. The table was warped. It warped when I machined the underside to put in the ball screws. I actually had a replacement table, but the replacement casting requires some machining and fitting, and I just never found the energy to address that. There was also some backlash, a little binding in Z. There were some things that I could have dealt with, but again, I just couldn't find the energy. So I offered it up to my patrons. One of them bought it, and that machine now has a new loving home. The other problem with that machine is that I really never felt like I could show any of the details of the CNC conversion because I used the plans that I bought from Haas Machine. So it wasn't my intellectual property, it wasn't mine to share. I have no idea if Haas Machine is still a going concern. I have no idea if Daniel Kemp's even still around. Haven't seen him in the forums for a while, but regardless, I didn't feel like I could share that. So I wanted to start fresh with something that I knew I could share without any limitation for people who wanted to follow along and do something similar. So I looked around and I settled on this machine. This is a Precision Matthews PM-728VT. We'll talk a little bit more about why I chose it in a minute. But I reached out to Precision Matthews and asked them if they would be interested in sponsoring this project. And they said enthusiastically, yes, what do you need? So they sent me the mill, they sent me the stand, they sent me a double nut factory ball screw conversion kit, and they sent me the electronics to control the spindle. They also sent me a discount code. So there's a discount code down in the video description, and if you buy a PM728VT mill and any of the accessories included with the machine on the product page, you get a 5% discount. And full transparency, I also earn a commission, which will help me to pay for all the stuff that's sitting on that table over there. So why the 728? Why did I pick this machine? Well, this machine is a part of Precision Matthews' Ultra Precision line, meaning that the machine is 100% made in Taiwan. It's the same as the 935, the knee mill that I have, and that machine has been fantastic. And these machines have an excellent reputation. I know a couple of people that own them, and I have handled one at the Barzy Summer Bash, and this is a solid little machine. The spindle is fantastic. I've tested this one, and the run out on a pin held in an R8 collet is less than 1/10,000th of an inch total indicated run out, which is fantastic. This machine also has a 4,000 RPM spindle, which is double the speed of what I had on the Grizzly. It uses a censored brushless DC motor, 1 horsepower with a belt drive, which again is a much better fit for CNC than the Grizzly. It has scraped or at least flaked ways, and the machine has a one-shot oiler. And I don't know about the stock one-shot oiler pump, but it has all the fittings and it has all the machining in the saddle and in the slides to distribute the oil, which was another pain point with the Grizzly. Now this machine does have a big brother. This is the 728. There's also the 833, which is a similar mill with similar features, a little more than double the weight and greater travels. Now that machine is very popular for CNC conversions, and I looked at it, but I opted to go with the smaller machine for a couple of reasons. One is this machine is a little bit less expensive, but it's also a lot easier to move around for somebody in a home garage shop. This is really easy to move around with an engine hoist. Yes, you can move the 833 around as well, but it's twice the weight. The machine is bigger, it's a little bulkier. I think this is a much more attractive size for the average home gamer. And it's kind of the size that I wanted. This is about 100 pounds heavier than the Grizzly that I had in here. And from what I've seen of the machine, I expect the rigidity to reflect that. The other thing that makes this particular machine very attractive for a CNC conversion is that Precision Matthews sells factory ball screw conversion kits. So they sell the 3-axis screws either with single or double ball nets. They are C5 rolled screws, which again is another step up in quality from what I had in the Grizzly, and they just bolt in and don't void the factory warranty. You have the motor mounts, and the bearing blocks comes with angular contact bearings. I'm not totally sure I'm happy with the bearing configuration. We'll look at that when we get there, but that makes this really simple because you don't have to do any machining to do the conversion. They also sell a small PCB that interfaces with the driver board in the spindle control, so that you can drive the spindle directly from a CNC controller without having to do anything exotic or replace the spindle motor. Oh, and for reference, this machine weighs in, just the machine itself, at about 378 pounds, which is what, 170 kilos. So what is all this stuff? It looks like an awful lot, and it kind of is an awful lot, but let's talk through what this all is, and then we'll look a little closer at some of the parts. This is the ball screw kit from Precision Matthews. Comes with the ball screws, the motor mounts, some covers, some angular contact bearings, and all the stuff you need to bolt that onto the machine. This is the MASSO G3 Touch CNC controller. I also got the optional wiring module that simplifies the wiring with just a couple of cables down to the control box. I got a couple of relay modules for controlling accessories and the MPG pendant. This is some miscellaneous stuff from McMaster Carr, some motor couplers. This kit comes with motor couplers. I actually bought a different style that I think I like better. We'll see when we actually get to the conversion. This is the spindle control PCB from Precision Matthews, a power supply for the ClearPath Servos that I'm going to use. This is actually a tower light. I've got some DIN rail, got some finger duct. This is actually a pneumatic cylinder. I'm going to have a go at doing an automatic power drawbar. Got a bunch of things, proximity sensors, connectors, relays, circuit breakers, pneumatic valves, contactors, power supplies, fans. I did design some custom breakout PCBs to try to make the wiring easier. That's here. Got a bunch of parts from DigiKey and Mouser, part for the PCB, some for the cabling and wiring. I actually picked up a probe and a touch sensor from DrewTronics. I've got ClearPath Servos from Technic. This is the electrical cabinet from Saginaw. I did also pick up a servo brake because on the Z-axis with a ball screw, the servo doesn't provide enough resistance to keep the head from falling, so we need a brake. And I bought a bunch of Tormach TTS tool holders and the specialized collet for that. I think that's everything that's here. Let's dig in and take a little closer look at some of it. This is the MASSO CNC controller, or rather, this is the touchscreen module. And yes, I know it still has the plastic film on it, and we will peel that off in a future video once we get this installed. I really would like to avoid scratching the screen. And yes, I already did lose one of the screws. I'm either going to have to find it or get another one. Now inside this is the controller itself. Now this is just a single PCB in here, and that is the entire controller. It's got HDMI outputs and connections for everything that's inside here, and then it has, you know, little terminals all around the exterior for you to attach your screws. Now in this case, the terminals are no longer on there. I'm using the wiring kit, and that's a PCB here that they provide. Well, they provide, you have to pay for it. That snaps down, connects to all of the terminals, and provides a couple of D connectors, so you have two 37-pin cables. These go down to your wiring box and connect to this module that then provides duplicate connections for all of those terminals. So you can do all of your wiring in your wiring cabinet, and then you just have these two D-sub cables that go between the touchscreen and the cabinet. Otherwise, you'll end up with every sensor, every actuator, every pneumatic valve, your limit switches, your MPG pendant, everything all wired and coming into this one cabinet. You have a great big bundle of wires. I'm going to mount this thing on a monitor mount near the machine, and I don't want that. So I paid for the wiring kit. I also bought a couple of relay modules, and the MASSO has TTL outputs to drive specifically these relays, and then these can switch to 24 volt or 120 or 240 volt power to actually control accessories. Also spent the money and picked up their MPG pendant, and this is just a simple axis select, resolution select, and an MPG dial, and an additional e-stop switch. And this e-stop switch is wired in series with the e-stop switch that's here on the machine, so you can use either or both. The most important thing, I think, to say about the MASSO is that this is entirely self-contained and does not use a computer. The screen is just connected up to the board, the microprocessor is on board. You can bring in your G-code either over the network, this does have Wi-Fi, or there is a USB port here, and you can bring in your G-code with the USB port. It does connect to their cloud services, and so it's provisioned up for presumably licensing, but you can also monitor the status of jobs that are running on the machine remotely, if you want to. In my shop, that's probably not a big deal because I'm just a little one-man shop, but as you'll see, the fact that something isn't actually needed doesn't necessarily stop me from doing it if it seems fun or interesting. The other thing that I would say about the MASSO is that it is opinionated. That's a software development term, and basically it means that they have a way that they do things and you need to conform to that way of doing things, as opposed to it being customizable and having a huge number of flexible options. Do you want a tower light? They have a way that they do that. Do you want to do homing? They have a way that they do that. Do you want to do a touch probe? They have a way that they do that. You just do it their way and everything will work. Something like Mach or the Acorn, you have ultimate flexibility because you can write a bunch of scripts to make anything work any way you want. But you also have to write those scripts to make the stuff work the way you want. And so this is an approach where you just do it the MASSO way and stuff just works. Now there's lots of flexibility, like they have a lot of options, they have a lot of stuff that they support, but if you use those features, you're going to use them the way they want you to use them. And honestly, I find that lack of flexibility refreshing because it means they can just tell me what to do and I don't have to go figure it out, design it myself, and worry about all the trade-offs. Does that mean that I have limitations? Yes, it does. For example, I don't think I can use the hard stop homing on the ClearPath Servos. I have to actually have homing sensors, but we can live with that. I think I already mentioned it, but I am planning to use ClearPath Servos for this conversion. I used steppers when I did the G0704 originally, and steppers can work fine, and they are quite a bit cheaper than servos, but they have issues, especially when you start getting into larger motors with higher inductance windings. They have more torque, but they lose that torque when they go faster. Servos don't tend to suffer from that nearly as much. The other nice thing about the servo is it is entirely self-contained, at least the ClearPath servos are. The drivers are all on board, the motor's on board, the encoder's on board, and these do not lose steps. Now, obviously you can overpower a servo, but you will get feedback that that has occurred and the CNC controller can shut down. So these servos are compact, they're powerful, they can run fast without losing torque, and I've used them on other machines, and like especially I use them on the surface grinder, and I am very, very happy with them. This is a NEMA 34 that I'm going to use on the Z-axis. This is slightly bigger than the motor that I think Precision Matthews recommends, but it's one that I had left over from the grinder project. This one specifically is the 3421S, and for the X and Y axes, I'm planning on using the 2321S, and this is the enhanced version with the axle seal. Now, this is the one that I settled on. It's not the one I was originally planning on using because I actually had some bigger NEMA 23 motors left over from a previous project, and I was planning on using these. Now, when you select a servo motor, there's a few things you need to be concerned about. Does it fit? Does it have the required torque? And can it reach the maximum speed that you need? And so in a NEMA 23, this is the largest, torquiest motor they have that still has a maximum speed that's fast enough to reach the rapids that I want on the machine. The problem that I ran into after I already, I had one and I bought another one, is that the Precision Matthews ball screw kit comes with shields that go over the motors. and this will not fit under the shield. This one will, so I went ahead and picked it up. If it works, great, and I'll save this for another project. If I need more torque, then I'll do some custom shields. I did pick up a NEMA 34 electric brake. So the way this works, this goes on the NEMA 34 motor, and you have to apply power to release the brake. When the power's off or when the servo shuts down, the brake clamps down and prevents the axis from sagging by back driving the ball screw. And then for power, I am running the ClearPath IPC5. I think one power supply is going to be sufficient to run 3 motors. I plan on doing the electronics to potentially run 5, so I left some room in the box for another power supply in the future if needed, but I'm pretty sure that 1 will work. Can you use a cheaper power supply? Yes. I use these because they work. And they work really, really well. And they have a bunch of extra features in them for dealing with the high surge current spikes and for dealing with back EMF that gets driven back to the power supply during deceleration. And it has provisions to dissipate that energy safely. The one other thing I'll say about the ClearPath is that their support is fantastic. Every project that I have ever worked on, I've run into something that I was uncertain about, and I was able to contact their applications team, and they walked me through it, gave me the answer, or even got on the phone and helped me solve the problem. So that's just been fantastic. I could not ask for more from them. When I did the G0704 conversion, I did all of the probing, touch off, and tool length setting manually, meaning I actually measured all the tool lengths with a height gauge, and I used a pin or a feeler gauge to touch off on the workpiece. Decided I did not want to do that this time. I wanted to use a probe. So I looked around and I decided to get this one. This one is made by DrewTronics. Not a sponsor, though my understanding is that Andrew is a fan of the channel. This is a wireless touch probe. So this goes in the spindle and the machine can move around and probe the workpiece to locate the edges of it, locate the center of it, locate the height of the top. So this is a 3-axis sensor. You can use the ruby tip on this, probe from any direction. And this one is wireless. So it has a battery, it has a series of infrared transmitters, and it has a receiver that will mount on the mill within the line of sight of the probe. So this allows me to just put this in the spindle, probe, and then pull it out of the spindle and not have to worry about hooking up a wire. This could even go in a tool changer. So that will give the mill a way to locate the workpiece to measure the length of the tool. I picked up this touch-off sensor, and this is also from DrewTronics. This bolts down to the mill table and has a pad where the machine can come over and touch the tool to measure its length. Now, I believe you can also hit this from the side and measure the tool diameter, but I don't have any experience with that. We'll figure this out as we go. It may already be obvious, but I'm planning on using the TTS Tooling System on this machine. If you're not familiar with TTS, it works in an R8 spindle, and it's something that Tormach has used on their machines for years. And the system consists of a special short R8 collet that holds the tools. And what's special about this is the collet's actually shorter so that it gets sucked up inside the spindle nose so that the spindle nose surface is exposed. And then all of the tools are held in tool holders that have this dual register surface. So it's a 3/4 inch shank that goes into that collet. And then they have this ring around the outside that pulls up against the flat end of the R8 spindle. So the collet takes care of centering it and holding it, and it pulls it up, and that surface registers against the spindle nose. So this tool that's held in this case, an ER25 collet will always be exactly the same length relative to the spindle nose. And then eventually we'll put a power drawbar in this thing, so this will release automatically. You can pop it out, pop a new tool in, and suck it up and go on to the next machining operation. Sorry, ER20. Couple of things to note. One is that there have been different collets over the years, and I actually have one that I used on the Grizzly right here, and you can see that these are not the same length. The newer collet is actually shorter. I put the older collet that I have, it's Tormach branded, put that in the spindle of the Precision Matthews mill, and it actually stuck out a little bit. It was like touch and go whether there was enough gap in the top of the tool holders to avoid interference, but it was close enough that I was considering actually grinding it. But then I just went ahead and ordered a new one just to see. The new ones are actually made by Lindex, and I was pleasantly surprised to find that the new ones are shorter and work just fine in the PM-728 spindle. So if you are trying to use the Tormach tooling system in a Precision Matthews mill and your collet is sticking out too much, pick up the new Lindex collet. It's shorter. The runout on this thing is also fantastic. I threw this in the spindle nose of the new mill and put a 3/4 inch gauge pin in it, rotated it slowly, measured less than 1/10,000th of an inch total indicated runout. And I've measured the taper in the spindle nose too, and it shows basically 0 runout. So these are really good collets. I was actually pleasantly surprised. The other thing I picked up while I was at it is one of these tightening fixtures, and all this is just a one-way bearing so that you can bolt this to your bench, put the tool in it, and it can rotate one direction, cannot rotate the other. So you put it in one side and use it as a fixture for loosening collets. Stick your tool in the other side, and you can use this to hold the tool while you tighten the collets down, and it prevents you from having to use a second wrench on the flats in here and makes things a lot more convenient. Wiring on a CNC conversion is always the biggest challenge if you want the thing to be neat and tidy, look good, and work well. So some things like these inductive proximity sensors use an M12 circular connector, and they use a cable, something like this. And you can either buy connectors and put these together yourself, or you can buy overmolded cables like this. My plan on this project is to use these overmolded cables for everything. I bought these from DigiKey. These are Amphenol brand, so it's a quality cable made by a reputable manufacturer with good overmolding, so I'm not messing around soldering cheap connectors that I got off of eBay like I have on previous projects, and they led to all kinds of frustration. So I'm planning to do everything on the machine with these overmolded connectors. And so that means actually converting a bunch of the devices to utilize those. For example, these are the pneumatic valves that I'm going to use for the mist and for to blow air off of the touch sensor and some other things on the mill, including a power drawbar. And these normally have individual connectors along here that you hook up individual wires to. I instead designed this housing that holds all the connectors. They snap onto all the valves, and it provides a single 8-pin M12 connector, so I can use a single cable back to the control cabinet. And then at the control cabinet, I need a whole bunch of connectors, which means there'll be a whole bunch of wires inside the cabinet. And instead of doing that, I've designed some custom PCBs that will hold all of those connectors and make the wiring simpler. So all the connectors go on one side, these go through a panel, and I've got, all the connectors here. Ordered this stuff from MASSO. Their shipping was not awesome, but these are available from a number of manufacturers. So these are just PCB mount front screw nut connectors, and I will put a whole bunch of them in a PCB. I've got provisions for connecting all the wires that are needed inside the cabinet, and this will make things a lot simpler when we go to wire it up. Now I got some 3D printed fixtures to hold these in position so that they're all aligned perfectly when I solder them on. And I've also done another board for the servo connectors and the servo power connectors. And I've got all the components in here to populate them. We'll do a video on these specifically. Last thing I'll show you is this signal tower. I picked this up from Automation Direct. When I was reading through the documentation for the MASSO controller, I realized that it had direct support for a signaling tower. So this is just 3 lights that indicate the state of the machine, and you'd put this up so that you can see it from a distance. And you'd use these in a shop where you have a whole bunch of machines that are all operating at the same time, cycles are running, and you need to be able to just look across the shop floor and see which ones need attention. Do I need this for my little mill conversion in my little one-man residential garage shop? Absolutely not. But does it sound like fun? Yes. So I had to pick one up. So the MASSO has outputs for this. You just configure it for the 3 lights, provide 24-volt switched power for them. And it has some very basic things. The green light's on when the cycle's running. If it stops and needs you to do something like change a tool, the green light flashes. The yellow light comes on and flashes when you have situations like the machine has been powered up, but it has not been homed yet and it needs attention before it can run. And then the red light flashes for things like e-stop. So I thought this would be fun. It's totally unnecessary, but again, if you're going to go to the trouble of doing something like this, it might as well be fun. Well, what you've seen today is the culmination of about 2 months worth of work that I've been doing in the background. Planning, designing, selecting components, figuring out what I was going to do, getting everything ordered and waiting for it to all get here. And I think we're finally ready to start the project. Now I'm going to be making videos about the individual steps in the project. I'm going to focus on the interesting stuff and I'm going to skip some of the boring stuff. For example, I did not make a video of getting this machine out of the crate and setting it up on the stand. But I will share one interesting tidbit. If you use the discount code to buy one of these machines and you get one of these bases, be very careful when you install it. All the hardware for the base to bolt all the parts together is poured into one bag, and there is a mix of 5/16 fasteners and M8 fasteners. The bolts that hold the mill to the base are M8. All the bolts that assemble the base are 5/16, and they look virtually identical and they're all in one bag. So do yourself a favor, pour them all out, sort them out before you start. I didn't do that and I ended up getting frustrated. I ran a tap through a couple of the nuts trying to fix what I thought was a mangled thread before I figured out what was really going on. Why is it that way? I don't know. I'm told that that's just kind of the way they do things in Taiwan sometimes. So keep that in mind. Thank you for watching.